Hi students, this is a problem from refraction of light at curved surfaces, 10th class. And the problem says a body is flying vertically down toward the surface of water in a pond with constant speed, and there is a fish inside water. If the fish is vertically below the bird will appear to the fish to be. The bird will appear for the fish to be dash 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 dash. So now I have read the question. When can we say that we have understood the problem? If you are able to explain the problem in your own words, or else in our own words, we can say that we have understood the problem, right? So of course I did not read only once. Have been teaching this from been teaching the same problem from nearly 8 years, right? So there is a bird in air, there is a fish inside water. Fish is observing bird, and bird and fish are on the same line, means they are vertically, fish is vertically below the bird and bird is vertically above the fish, and bird is moving with a constant speed vertically down toward the surface of the water, or else toward the fish, right? So if you are able to say all this, you have understood the problem. Now, how will the bird appear to the fish? Whether it is farther away than nearer away. Whether it appears for the fish, bird is moving faster or slower than actual speed. They are what the questions given in the textbook in the problem. We can add one more. When the bird is at a certain point, will it appear smaller than the actual size or larger than the actual size? We can add this one more question to this, right? So before going to the problem, let us generalize. Means whatever the object in rarer medium is observed from a relatively denser medium, not only here fish, whatever the object might be, whatever the logic we apply here is applicable to everything. They may ask you in examination, they may change the question. How will the fish appear to the bird? Right? So generally in CCE, they won't ask the same question. Question will be same, just they will change a little bit. So first of all, let us generalize the topic. Let us take two cases. What are they? Case 1. Case 2. Case 1 is there is an object in the rarer medium that is observed from denser medium. I am not writing from where it is observed. Now there is an object in denser medium. It is observed from rarer medium. How it will appear? Right? It is generalization of the problem. This is generalization because bird is in the air and fish is here somewhere. That is observing. Fish is observing the bird object. Right? So first of all, what you do, whenever we use ray diagram to locate the position of the image, first of all we have to take two rays in any direction. For convenience, we will take always one ray along the normal. This ray, however, won't deviate, will go in the straight direction. You know that, right? It is not a topic of discussion. And take another ray in any direction you like. I have taken ray here. This is point of incidence. At the point of incidence, we have to draw a normal. And if you confuse, first of all, draw the original path of light. Means if there was no this denser medium, the light ray would have gone in the straight direction. But as the light ray is going from rarer medium to denser medium, it will bend towards the normal. This is towards normal, this is away from normal. Keep one pen. So it is towards normal, this is away from normal. Now, if we observe the refracted rays, they are diverging. So whenever the rays diverge, it means that they are coming from some point. They are going away now. So this one here nearby, and here somewhat nearby. Means that these two refracted rays are coming from some point. How to locate that point? So keep scale. You have to use the scale. You should not draw like me. You must use scale, ruler, not scale, ruler. So extend in the opposite refracted rays. Extend the refracted rays in the opposite direction to locate the position from where the refracted rays are coming. This is the this is the refracted ray. Keep scale and draw line with dotted lines, not with solid line, because there is no ray, right? So it is the position of the image. Means the image will be farther away than the object, right? Same bird, original bird, image of the bird. So bird appears as it is farther away than the actual position, right? Let us go in this case. In this case, it is like you have in 9th class an experiment. Same example. Take a glass, keep a coin, observe from the top. Do you remember? Observe from the top and move away until the coin goes out of your vicinity. Right? Right? Do you remember? And pour water in the glass and the coin will reappear. Did you remember this? So, if you don't know, you try this. It is not a big, very long, very difficult experiment. Now, coin, object, one ray along the normal. It is point, right? Normal to the surface of the water. So here the light ray won't deviate. It will go in the straight direction, but it will refract. Here speed will increase as the light ray is going from water to air, denser medium, rarer medium. Speed will increase. It will refract, but it won't deviate from its original path. That is what we have to remember. Now again take from the same object a ray in any direction you like. It's up to you. At the point of incidence, draw normal. Right? Now, locate the original path of light. Now, light ray is going from denser to rarer medium, so it will bend away from normal. Once again, if you observe the refracted rays, how are they? They are diverging. If any rays diverge, it means that they are coming from some point backside. So to locate that point, we have to extend the refracted rays. Right? So this is the point. It may not bend this much. According to the bending of the light, this place will depend. So this must be also extended in backward direction. The both extended rays in backwards, they will meet at some point which is nearer than the actual position. Mean that is what coin will appear as raised. Right? This will come into the vicinity of the person. Here it is not visible. Right? First of all, coin up here went out of vicinity, and this ray will be visible to the person. That is why this person can see the coin back. Right? So what is generalization? An object in denser medium, when observed from relatively rarer medium, appears as it is raised, right, and appears as somewhat larger. A lemon in glass of water appears larger. When any object which is nearer than the nearer, observe, it will be larger, somewhat smaller. As the object goes away, it becomes smaller. Eighth class concept, right? So now let us do this mathematically, right? Rarer medium, farther away than the